Hello everyone, welcome back to class. Today we'll have something to prove. We're going to prove that the sum of all the natural number is going to give me this. Sum of all the natural number is going to give me this. So this is my plan, this is my aim, this is what I want to get by the end of the day. So this is what I'm going to do. I will have n, my r begins from 1 of r, is going to be of this nature. I will say it's going to be 1 plus 2 plus 3 plus 4, or I should just end it at 4 here, dot 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 plus n minus 1 and plus n. So you see it, this point to this point. I can say this is my equation 1. Then if I take the reverse of this, I will have the summation from 1 of r. If I take the reverse, it's going to be, I'm starting from this point now backwards, so it's going to be n plus n minus 1 plus n minus 2 plus n minus 3 plus dot 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 plus 1 plus, okay, let me put plus 2 plus 1. That's my equation 2. So I have this to be this, and I have this also to be this. You can prove this by induction. So I just want to give you that this will give you this. By induction, we're going to prove this. So if I add the two equations now, equation 1 plus equation 2, I'm going to have this plus this. This means 2 I'm going to have r from 1 of r to n here equal to, I'll add each term, so this to this, this to this, this to this, continuous like that. Then I'll have the last one, this to this, this to this. Do you understand? Okay, so if I add now n plus this, I'll have n plus 1 plus this. I have n minus 1 plus 2. I'm going to have n plus 1. You see that? Plus 2. So n minus 2 plus 1, I'm going to have n plus 1. So if I do continue here, it will continue till I have n minus 1 plus 2 is going to be n plus 1. And plus this last one now is going to be n plus 1. So you see, everything here is n plus 1, n plus 1, n plus 1 till the end. But remember, I can have something like this. I can have 1 plus 1 plus 1 plus 1. Or let me just, okay, let me use something like this. It will still give me a note. I have 2 plus 2 plus 2 plus 2 plus 2. I can say 1, 2, 3, 4, 5. That is 5 times what? Times 2. Because I have like this. So if I have n plus 1 into n places, because I don't know how many I have here, but into n places, it's going to be something like this: n times n plus 1, right? It's going to give me something like that. So if the sum of all this gives me this, it means that this will give me this, right? So I'll put it like this. I have 2, the summation when I have r for n is going to be n into n plus 1. So divide all through by 2. I'll have n this r is 1, r here is equal to n into n plus 1 all over 2. You say q e d. Okay, so you see, we're able to prove that the sum of all natural number 1, 2, 3, 4, 5, 6, 7, 8, 9 till infinity, it's going to give you this. And this is a very simple. So if you want to know the sum of the first 10 natural numbers from the first 10 natural numbers, just put your n as 10, and whatever you get becomes the sum of the first 10 natural number.